Right, guys, hopefully everyone's back in the room, refreshed. I'll hand straight over to you, Tom, to kick into your subject.
Okay, good afternoon, everyone. Can everyone see me? Can everyone hear me and see my screen?
Yep.
Nice, perfect. I see Chris nodding. Perfect. Welcome to my living room. I'm quite eager to get back in front of real life people. On that topic, if you feel comfortable doing so, please do share your webcam. It's nice to be speaking to real life people as opposed to avatars. So if you want to, please turn on your webcam. Be nice to have some social interaction. Also, any questions, comments, or thoughts throughout the presentation, please just let me know in the conversation. I'll monitor the chat window myself going through. Okay, well, thank you for joining. In this presentation, I'm going to take you through a state of grace. Now, I'm not going to be talking about state machines. Instead, I'm going to be talking about different scenarios your software could find itself in. So I'm hoping to show you a bit of a magic trick. The magic trick I'm going to show you is how an object can alter its behavior when its internal state changes. And so the magic is the object will appear to have changed its class. Now, as much as I want to take credit for this, there are no original ideas in this presentation. Everything in this presentation comes from the good book. This book being from the Gang of Four, Design Patterns, Elements of Reusable Object-Oriented Software. So to start off this presentation, I want to talk about an application or a helper loop I recently wrote for an application. This helper loop had to basically take images, take frames from a camera and save it into a TIFF file. Now, those of you who don't know, a TIFF file is a multi-page image file. It can be used to store raw data of images, and it's, as I said, multi-paged. Now, as I developed the TIFF driver itself and the helper loop, I had a pretty good idea of the function calls I had to make. Those function calls included like creating a file, checking the file size, publishing a frame to the file buffer, going from that buffer into the file itself, deleting the file, closing the file, if an error occurred, etc. So I knew all of the functions I had. And at this stage, I've noticed that a lot of, let's say, novice or new Labview developers would jump into creating something like this, where we have a queued message handler, and every case in this case structure would be for every function. So we receive a message, and that message could be, create the file, add an image to that file, close the file, etc. Now, I'm not so keen on that because, as you see here, we have a message DQ function, which implies the API for this helper loop is going to be create file, check image size, add frame to buffer, publish frames to file, etc., which is an overly complicated API for a helper loop. Instead, I wanted this API to be as simple as creating a file, writing a frame, closing that file, and stopping the helper loop. And there's a couple of different ways we could implement that. The most common way of transferring between our external public API and functions in our helper loop could be to do something like this, where this is a screenshot from the TLB Prime framework, where we receive a request called write new frame. And when we receive that request, we say, OK, we want to create the file and add a frame to the buffer. A similar thing also appears like the JKI state machine. James Powell's messenger library also does a similar thing. It's fairly common. The difficulty comes from this as a reminder. A reminder, an actor can never control the order or schedule of messages it receives. Now, I'm coming at this from an actor framework point of view. I'm an actor framework fanboy, but whenever I'm talking about an actor, I'm just talking about a loop. In this case, a helper loop, just a while loop. Now, this is implying that in different software scenarios, I might need to handle those messages differently. If I receive a write frame message before I receive a create file message, my software needs to handle that. Equally, if I receive a close file message, but there's no file to close, I don't just want an error to occur. There would be no point in that. So instead, I look at the different scenarios. The different scenarios I could have in this particular helper loop could be my helper loop is currently idling, or my helper loop is currently publishing. If I'm idling, it means I'm just sitting around waiting for a message to happen. I don't currently have a file on the go. There's no active file. So I'm just sitting there waiting for a message. If, however, I'm publishing, that means I do have an active file and I can stream directly to that file. Now, the reason I bring up both scenarios is because we need to handle them differently. If I'm in an idling state or scenario and I receive a message of write new frame, that means I need to create a file and then add frame to that buffer. However, if I'm already in the publishing state, then it means I just need to write the frame to the buffer. I don't need to worry about creating the file. Okay, now with that in mind, what I've seen is people end up with something like this, where we have two separate loops. One loop is a message handler. It receives the messages from the public API and essentially converts them into internal requests like create file, add frame to buffer, etc. That's sent in a queue. This is the AMC reference library, but think of it as a queue, gets received down there, and functionality is executed. Other people might put this in the same loop, like James Powell's messenger library. You'd have this sort of code in the same loop. Now, just by show of hands, who thinks this is a good idea? Good. That was one of the rare occasions where I don't want any audience participation, because I agree, it's not a good idea. Having asynchronous code is great in Labview, but don't do it for the sake of it. Instead, I want to ask the question, so unmute your microphones. Who can tell me what's the fundamental way we define functions in Labview? How do we define functions, methods, etc. in Labview? Unmute your microphones, you'll get 10 points if you answer correctly. I promise you, if you're thinking about it more than 5 seconds, you've got the wrong answer.
Create a VI?
Yeah, absolutely. Jasper gets 10 points. A VI. A VI is the fundamental way that we can implement code reuse in Labview. And it's important that we don't lose sight of that. So all of those functions are sub-VIs. And so we can take those sub-VIs and, well, use them. So instead of creating this asynchronous message handler for the sake of it, we can replace that code with our steps. And I've mentioned him a few times, but James Powell has a great presentation called What Would a Sub-VI Do? It's making the most advantage of data flow that we have in Labview. So instead of creating these frameworks, we can just go back to fundamentals, where if we're in the idling state and we receive the message write new frame, we can create a file, publish that frame to a buffer, and C here could be checking for errors or another piece of functionality. However, this type of nested structure has its own other issues. So Jasper's question here, is James Powell's presentation public on YouTube? Yes, if you go onto YouTube and just search what would a sub VI do, it'll come up. Now, having nested structures like this has its own set of issues because we have 4 items in our public API: create file, write frame, close file, and stop. And we have 2 different states or 2 different scenarios our software could be in. Multiply those together, and we now have 8 sections of code. And we now need to determine, okay, what's going to happen in all 8 scenarios? So all possible possibilities of state and request. Now, the way that I document it and the way that I design my systems using state patterns like this is to use a truth table. Now, I first came across truth tables in, I guess, elementary school when doing Boolean algebra or digital control circuits. We can create a truth table like this, where we might have 3 different switches or sensors, and we can find patterns in this truth table, convert it to Boolean algebra, and then create an implementation from that. We can do the same with our code. With the state pattern, we could have our states on one axis, our requests on another axis. So on the left-hand side, we have publishing and idling as our 2 states. On the top, we have our public API, create file, write frame, close file, and stop. Even in each of these, I guess, products, in each cross product, we have an action. We have whether or not we expect it to be in that location of code. And we also have what's the next state going to be. So when we start using our software, or this helper loop starts up, I imagine we're going to start off by wanting to create a file. So we create a file, we expected this to happen, and our next state is publishing. So we can now switch over into the publishing state. If then we want to write some frames, there's a bit more logic in here just to make sure we're handling our frame buffer correctly. But ultimately, what we're doing here is getting some image data, writing it to a buffer. If then when we go to close our file, we write the last frame, close the file. If the file's empty, let's just delete it. If then we switch back to the idling state, in which case we can either create a new file or stop. And you'll see there are some different colors here. The green color is expected. In ordinary use, this is how we expect the code to be used. Create a file when we're in idling, write a frame when we're in publishing. We might have some corner cases. So as we're publishing, frames, we might get a request to create a new file. And I would say that's a corner case. I'm not going to produce an error if that happens because perhaps the user is doing an experiment. So I work with microscopy and microscopes a lot. So they could be imaging like a brain slice if they want a new file for a different brain slice. So that's fine. I just write the last frame, close the file, and create a brand new file. Equally, I might have an emergency stop situation where I get sent a stop message, even though I'm publishing, in which case I can gracefully handle that situation. So I write the last frame, close the file. I log it to an event log just as a matter of course, because I shouldn't normally end up in that case, but I can still handle it gracefully. And just to flip back to a reminder we had earlier of an actor cannot control the order or schedule of messages it receives. Well, thanks to this truth table, we can now handle any message in any order, and we know what's going to happen. So regardless of the situation our software finds itself in, and regardless of the public request that's sent, I know that my software can handle it. Okay, now if we have a look at some G, we all like code here. This is how I've implemented it in this particular scenario. And where the state pattern lends itself quite nicely to documentation, where you can just double click, have your different states, have different functions. But if we zoom in, our outer case structure is our current state. So here I'm currently idling. The inner case structure can be a request. So we've just received a request, create file. We're in the idling state. Now, so if we're creating a file, that means our next state should be publishing, because now we have an active file that we're working on. So we go to the publishing state. Well, let's not lose sight of the code itself. These are the sub-VIs, which Jasper correctly said were the fundamentals of code reuse in Labview. And here are all 8 different states. So for every public API call, for all of the states available, we're able to handle it. So if we switch back to our opening statement of, we're going to allow an object to alter its behavior when its internal state changes, the object will appear to have changed its class. Well, that's what we're doing here. Depending on whether we're in the idling state or the publishing state, the code is going to behave differently depending on the state it's in and the request that we receive. Okay, keep your questions coming. I do have half an eye on the chat window. Okay, so that was an example using case structures. Now, okay, Nathan has a question. How do you handle messages coming from external actors? Won't it interfere with your running logic? Well, messages coming from external actors, we act on sequentially. And if I just go back to one of these slides, because we receive those messages sequentially, the nice thing about data flow is we can maintain our statefulness. So I know that this code must execute and I must go into the publishing state, and all of that data gets stored in my shift registers. So the next message that gets received from an external actor must will be performed on the new and updated state. So if I'm halfway through this code and I receive another message, that's fine. Labview is going to continue executing this code, store it in the shift registers until the next message is received. It's a nice thing about G. Did that answer your question, Nathan? Okay, I'm going to accept that as a yes. Okay, now the example I gave so far was about case structures, but if you've listened to me for more than 5 minutes in any other presentation, you'll know I'm never more than 5 minutes away from talking about objects and object-oriented programming. So, which is where we switch to this book. For the rest of this talk, basically, I'm going to be talking about classes. And to demonstrate how we can use the state pattern in object-oriented programming, where instead of a case structure, we have dynamic dispatch, I'm going to do a demo. And because it's Labview, I'm either going to do an ATM demo or a car wash. And I believe we're in for an ATM demo. So let's bring up some cash machine code or ATM code. What I'll do is show you the functionality, talk through it, and then we'll switch back to the slides to go through how it actually works. Okay, here's my ATM, my automated teller machine. Remember that the definition I gave you in this book, which was with the state pattern, we're going to change the behavior of a class depending on its current state. And when we change state, it's going to appear like we've changed class. So that's what I'm going to show you now. We're currently in the state of no card. So this ATM, it's just been turned on. It has no card inside it. So if I click enter PIN, it says, please insert your card before entering a PIN. If I remove card, it says, well, there's no card to take. If I request cash, it says, enter your card before requesting cash. Okay, let's enter our credit card. By entering our card, we're now in the has card state. So this is where I'm saying our functionality should have changed. If I enter a card again, instead of saying card accepted, it now says you can only enter one card. If I request cash, instead of saying enter your card before requesting cash, it says you must enter your PIN before requesting cash. So let's enter our PIN, 1234, enter. We've now transitioned into the has PIN state. So my PIN is correct. Again, if I try and enter a brand new card, it says you may only enter one card. If I enter a PIN, it says you have already entered your PIN. But now I can request cash. Let's have 20 quid, 20 pounds. It says, please take your cash. Your remaining balance is, what's that, just under £1 million. It's been a good week at the office. Now, let's say I want to request 10 million. Was it 1 million or 10 million? Request cash. It says I have insufficient funds for that request. So I can remove card. I'm now in the no card state. So if I request cash again, it says you have to enter your card. The point I'm getting at here is, depending on the state I'm in, different messages appear. Those different messages are essentially different functionality in my code. Okay, we'll come back to have a look at the block diagram very shortly, but in case you're curious, it's simply a event structure inside a while loop. But let's have a look at how this is working through some slides. Okay, so my project setup, my ATM actions, i.e. my public requests, my public API, includes initializing the ATM, inserting a card, inserting a PIN, requesting cash, and ejecting the card. My ATM states, so the state or scenarios my ATM could find itself in, it has no card, it has a card, it has a PIN number, or it has no cash. For example, if the cash machine has been fully withdrawn, there's no cash inside, it just displays out of order messages. So like I did with my my TIFF image helper loop, I'm going to put, I think, my ATM actions on the left-hand side, my ATM states on the top, and we can create another truth table. This truth table goes through all of the possibilities, all of the possible scenarios or situations my code could end up in. So when I start up my code, I expect to start in the no card state, and my first function call is probably going to be initialize ATM. Next, I'll probably click insert card. And when I insert a card, I transition state. I go from no card to has card. And then my user's probably going to insert their PIN. So I go from has card to has PIN. And then when I request cash, I might remain in the has PIN state. Or if my ATM has run out of cash completely, I might go into the no cash state or the out of order state. And then at the end of the transaction, I might go from the has pin state to the has no card state. So has pin to no cards when the user ejects their card. Equally, I might go from the has card state to the no card state if I just enter my card and then immediately eject it. Now, the thing I really like about this truth table is I can map out how I, as a developer, think users should use the software. But as we all know, the biggest source of bugs in our software is the user using our code incorrectly. So I can now map out all of the possible ways it's the user's fault if they request cash whilst I'm only initializing the ATM, or they insert a PIN number when there's no card. And so I can now map out, okay, what's going to happen in all of these scenarios. At a very top level, I could just return an error, or perhaps there's the possibility to handle these combinations gracefully. Ultimately, we want to handle our code as gracefully as we possibly can. Now, not all of these empty spaces are going to be bugs. For example, as I mentioned earlier, if I'm in the has card state and I eject the card, I might go from this square down to this square. Okay, now I said I'm going to implement this using object-oriented programming. And so let's have a look at the Labview project. In my Labview project, I'm defining all of my states in this virtual folder states. And the behavior of all of those states is being defined within an interface. The interface being ATM states. So implementing this interface, we have has card, has pin, no card, and no cash. And the behavior I'm implementing within ATM states is eject card, has card, insert pin, and request cash. And if you're unaware, interfaces are a way that we can define behaviors. Even down here, we have our context class. The context is the thing that's going to be requesting these pieces of functionality. In this case, it's the ATM. The ATM sends a request to eject the card, initialize the ATM, insert the card, etc. Okay, there's a couple of questions here. Doesn't this become a bit too large? Sorry, a bit too big in larger applications? It seems exponential. How would you deal with this? You are absolutely correct. For every additional state, you are essentially duplicating all of your methods. The way I handle that is, in my top level interface, although we shouldn't be defining behavior in, let's say, our abstract class or top level interface, we could do if it's just to define an error code. If you, for example, if an override isn't implemented, we can return the error code. Equally, it doesn't actually take that long to develop this code. This design pattern has design right at the forefront. You must design your code. It must be designed properly, and a lot of the work is structuring it. Actually clicking and dragging your sub-VIs into the different states, not too long. Okay, Lewis has a question. This is a good way to handle unknown cases, but personally, I like to define critical sections of code to prevent unknown actions coming into my message handling helper loop. This reduces the burden of developing code for unknown events or messages upcoming into the module/actor. Sam Taggart recommends this approach in his article, Simple DQMH Do's and Don'ts. I'm going to come back to the reminder of an actor by definition cannot control which or what messages in whatever order it receives. In this truth table, you're correct, I can identify which sections of code could cause errors. If you wanted to, instead of creating an interface like this and implementing this using core object-oriented programming, you could use case structures and then have default states. That would be acceptable. I personally wouldn't do it like that. I like to methodically go through the cross product of all possible states. The reason for that is in the future, when requirements ultimately change, it means my framework is already set up and I can implement that change. I don't need to then create an extra section of code. How would you manage multiple API callers? For example, if you need to run multiple ATMs from a single server. I'm going to be showing you an example, sort of how I would handle that in the next section of this presentation. But ultimately, if we have multiple actually, could you reword your question? When you say manage multiple API callers, are you saying you have multiple actors sending messages to a single ATM, or are you saying you have one root actor and that's launching X number of ATMs? Whilst you're retyping that, the other question is, what kind of design pattern do we use in implementing the Labview? Sorry, what kind of design pattern do you use in implementing the Labview by using object-oriented programming approach? Basically, what you see on the board. Equally, if you happen to own this book, go to page 305 and it will tell you exactly how to implement this design pattern. If you don't own this book and you're interested in object-oriented programming, I would highly recommend buying this book or buying the head first design patterns, which is an alternative to this book, but written in a nicer, more conversational English. At the end of the presentation, I'll type out the title. I'll type out the title for you. But you're right. Depending on the situation, we're going to be using different design patterns. This is specifically looking at the state pattern, which is only one of 27 design patterns that exist in this book. Now, if we have a look at how this design pattern actually works, let's say the user inserts a card. So inside insert cards.vi, so inside this VI on the left-hand side, we double-click that, and then we're greeted with a nested dynamic dispatch VI. This dynamic dispatch VI is being defined by the ATM state interface. And it's, as I said, it's dynamic dispatch, which means depending on the object that's coming in, different behavior can occur. And coming out, we might have a different object going out. So a key takeaway of this slide is with state object in might not match the state object out. So this wire might be of a different class to this wire. If we have a look inside, this is all it's doing. We have a dynamic dispatch terminal coming in, and we're in the no card state here, but we can transition into the has card state, and that goes out. And if we have a look at the connector pane, and this is what I'm talking about, we have dynamic dispatch inputs in, and only recommended out. Just because you have dynamic dispatch inputs doesn't mean you need dynamic dispatch outputs. So this is a recommended output and dynamic dispatch in. A question that's come up, is it mandatory to use a DVR? There aren't any DVRs on the screen here, but I am using an in-place element structure. No, you don't have to use an in-place element structure. You could unbundle this, and then bundle on the other side. I just used an in-place element structure because I don't really know why. Perhaps I felt like it at the time. Okay. Now, were there any questions before I talk about the active framework? I'm looking on the participants window here, and I can see some Labview fanboys, and sorry, everyone's a Labview fanboy and fangirl, some active framework fans. So Nathan, you have a quick question. Feel free to unmute your microphone if you prefer.
Yeah, that might go a little bit quicker. So we used a similar setup in the past at ASML, but we found it to be quite hard to maintain in the long run, especially over years when states are being added and so on. It's kind of hard to keep track. How would you deal with that within this setup you have?
My number one response is going to be a boring one, which is documentation. An alternative response would be, if it's something you're doing on a very regular basis, I would think about creating some tools for this. It wouldn't be like if you have two nested case structures, it wouldn't take you very long to create a tool which goes through all of the different combinations of state and public API calls that you can document. You could create a project provider which right-click, new state, give it a state title, and by default, the functionality could all return error codes. But a lot of the legwork would then be set up for you. Typically, I use the state pattern actors for when I only have a couple of states. If I'm working with hardware, my states are typically an error has occurred. So I'm in an error state, I'm in a connected state or a disconnected state. There are probably some other states I could be in, but my states are typically limited to maybe 3, possibly 4 states, which means the exponential growth of code you're referring to does sort of have a maximum limit. Casey says, when does it make a difference whether or not the output is dynamic or static? The output terminal has to be static for the reasons of the objects going into the sub-VI might not necessarily match the object coming out of it. If you wired from, so if this was a dynamic dispatch output, the Labview would throw an error saying there's no data flow between your input terminal and output terminal. I suppose you could use the preserve runtime to more specific class function, but no, you couldn't because they're sibling classes. So that's why. The answer is Labview will tell you off. It will give you a broken run arrow. Will there be specific use cases to use in-place element structures? Possibly. I think when you read this book was written for, like, I think C++ and Smalltalk, which are by reference languages. So if you try and copy exactly what happens in here, you'll probably end up using DVRs. But all of the Labview examples that I've written from this book are implemented using data flow. So I'll say sort of yes and no. Thank you for sharing that link to the refactoring guru. That's where I got a lot of the knowledge for like a lot of the other object-oriented design patterns. Use object-oriented programming if you would like to prevent or limit the user from accessing your references. Object-oriented programming is the right approach. Yeah, absolutely. If you want to prevent a user from accessing anything, let's say a method, you can change to your access scope of a method. If you have a reference which you want to prevent the user from accessing, wrap that up in an object, and typically we call that like a proxy object, something that protects access to a reference. If you have a lot of data in your object, it's quite useful. Yep, classes can define data and the methods which communicate with that data. I want to use object-oriented programming, but it seems to be so complex. Can you give me some suggestions to be a master in object-oriented programming? Yes, I heard there's quite a good YouTube channel called Tom's Labview Adventure, which has a playlist about object-oriented programming. So I recommend you check that out, like, comment, and subscribe. Cool. All right, that's enough questions for now, but keep them coming. Let's talk about Active Framework. So I was doing a project recently. It wasn't for a customer. It was just a demo project, a prototype project, and it was just to control an XY stage. So I work in microscopy. My company produces microscopes. And so this was a very straightforward piece of software to move your translational stage up, down, left, right, forwards, backwards. Now, the user interface for this section of code I implemented using state pattern actors. So I'm going to focus on this section of the UML. And I have three different states here. I have disconnected, connected, and error. So the three states I was talking about earlier. If I'm in the disconnected state, everything is grayed out and disabled. If I'm in the connected state, everything is bright and green and all of these controls are enabled. And if an error occurs, everything turns red and the error message is displayed to the user. The way that I can switch in between these states is defined by this interface. If you haven't used interfaces before and you're using object-oriented programming, please start using interfaces. I know they're quite new, but it means you can do things like this, like you can define extra functionality, you can define behavior without integrating it with your class hierarchy. So it's a way of sort of dual inheritance in Labview. You can see this simple actor user interface is implementing a class and two separate interfaces. But I digress. In this interface, I have an entry method. When I enter a state, in this scenario, I'm using VI server to change the pane colors and make the controls enabled and disabled. If I exit a state, well, I can change the user interface. For example, this balloon pop-up message, I can make that hidden when I go into the disconnected state. Sorry, when I exit the disconnected state. And if I'm entering the error state, then I can show this error message on the user interface, show these buttons. But the question comes up of how do we change states? If you read into the state pattern in more detail, you'll come across terms like statefulness. Now, statefulness is how we can hold data whilst going in between different states. So how do we actually change from, let's say, the connected state to a disconnected state? Unmute your microphones. A 50-point prize is coming up. So in Active Framework, it all comes down to the overrides. We have our 5 classic overrides of pre-launch init, active core, handle error, handle last stack, and stop core. For those of you who want to go hardcore into AF, we have receive message. So if you're creating, like, I guess, a message broker or a way of forwarding messages, you'll probably override receive message. Now, can someone tell me what's the 7th override in Active Framework? Unmute your microphones, you'll get 50 points. Oh, a couple of you are shaking your heads. Okay, the 7th override in Active Framework is substitute actor. There are, I must admit, on my YouTube channel where I talk about Active Framework, I only focus on these top 5 overrides. I don't think I've made videos about receive message or substitute actor, so maybe that's my bad. But when we override substitute actor, the code you'll see looks like this. Now in Labview, and I think in, I'm going to say most programming languages, I won't say all because there might be ways to do it in some, you can't change in between sibling classes. So the way that we can change in between sibling actors is essentially to unbundle all of the data in our current actor and bundle it all into our brand new actor. And again, look at this connector pane. We have dynamic dispatch terminal coming in, but static dispatch or recommended coming out. That means the actor or class coming into this method can be different to the class going out. And because this is dynamic dispatch, we can override this functionality to append more and more data. So if some of my child actors or child classes have defined more data structures, well, I can unbundle those brand new data structures and bundle them into my brand new class or actor. And then this method is calling the parent implementation, because in Active Framework, we have a thing called stacked functionality, where every child descendant has all of the behaviors, so it has all of the functionalities of all of the parent classes. So in my lowest level class, I can transfer all of the data inside this sub-VI. This code is going to execute. So now I can transfer between objects, between actors without losing any data. Okay, as a very side note, as a side note for those of you who want to nerd out about OOP and interfaces, I have a question for you. I have an object here called Bob. I'm using the toMore specific class function to transition into a work interface. I do some methods, it then transition to a play interface. My question for you, and you'll get 30 points per correct answer, is what values come out of here? So this is the get object name function, and all this does is return the name of the current object. So unmute your microphone, or let me know in the chat window. Okay, Jasper says we'll get Bob, Bob, Bob. Who agrees? Who disagrees? Yeah, well, okay, you've got a couple of thumbs up now. Yep, Jasper is correct. So it's one of those, and AJ agrees, awesome. So occasionally I get the question when talking about state pattern actors, instead of unbundling all of the data and rebundling into a new object, can't we implement interfaces now? So if we defined all of our states as interfaces as opposed to child classes, could we not transition without, like, gracefully like this, instead of having to unbundle and rebundle data? And the answer is no, for the reasons that Jasper has said. The object going all the way through here is Bob. So here I have dynamic dispatch methods of sleep and sleep. The Bob implementation is always going to execute. I mean, here we have static dispatch, which the method defined in work and play will execute, but you can't change the interface and expect different behavior to occur in your dynamic dispatch VIs. The Bob implementation will always execute. Anyway, that was a side note, in case, just because that question's come up a few times before. It's quite interesting. Okay, last section, I promise. It's going to be about software wizards, and I bring this up because I found myself creating a couple of these recently. There's a question here from Alex. What about the two more generic class function? I mean, if you do that, you're going to get a broken wire, I'm pretty sure. I can remember I did try that in the demo code, but actually, I'll tell you what, I do have the code here. So when quick drop opens, so what about two more generic? So if I do Control P, it gets broken one arrow. Okay. And look at the UI, we still get Bob. Yeah, great question, great shout. I'm glad I was able to show you. Yeah, I've created quite a few software wizards very recently, and it got to a stage where I was seeing all of these different front panels, and I was thinking, well, okay, these can all be different states. And whenever I can define groups of behaviors, I start to think, okay, well, these are all clearly different objects. Now, the nice thing about software wizards is the transition in between all of those states, for the most part, can be predefined, where we can go forwards in this object array. So welcome, front panel, block diagram. We might reverse the order and go back to front panel and welcome, but ultimately we do this dance backwards and forwards through this array. Which means when we initialize our application, we can initialize it like this, where we can just append to this array of objects of welcome, front panel, block diagram, and palette, and that will either increase or decrease or change the order in which these individual screens appear. And the nice thing about this is you can easily store all of these objects to a file and load them into memory quite straightforwardly. So we start off our application and we just have an array of different states. This could be created dynamically or statically, just using a constant like this. But we get to our array of states, and when we go into the enter state case, let's say we can index that array. We can keep a register of where in that array we should be, and we enter that. We enter that state. We can look at the user interface reference, insert it into a sub panel, and get our title. And when we enter that particular state, we can launch it dynamically. That way you can have code running that's checking things like, is the user entered, sorry, are the values entered correct? If they are correct, then you can enable the next button. If they're not correct, then you disable the next button. So you can launch this piece of code to run in the background to handle things like that. Question, do you inherit from Labview base object, or would you create a wizard master object? In brackets, a wizard object is never later arrives exactly when it's meant to. Yeah, all of these inherit from a wizard object. And the reason why they inherit from a wizard object is boilerplate stuff like this is defined just in the wizard class, which means all child classes are able to launch their front panel dynamically without re-implementing the code. So I launch this code, place it in the sub panel, and that allows me to, I guess, replace what you see on screen. So I've now transitioned state. But what happens to this data? The user has either checked or unchecked these boxes, changed some values. What happens to that data when we transition? Well, if we look at the previous slide, notice how we're doing hex 100 here, which means call and collect. So we launch this code asynchronously, and we can stop that code, but the data values are going to stay in memory until we collect them. So when we exit a particular state, we can collect that data, parse it into the wizard object, like I mentioned earlier, and then we can replace that object in our array of states. So that's how we can keep track of all of our data. Okay, let's quickly see that in action. So here's my project. If we have a look in states, you'll see that this is the wizard state, which is the ancestor state. And then we have these concrete implementations of front panel, block diagram, controls and functions palette, and welcome. 10 points if you can work out where I got the inspiration for those names from. And then inside the main VI, when that loads up, we can run this code and click next through the different states. I can change some data, go back, then go forwards, and you see the data has remained constant. We have this idea of statefulness, and we can cancel. I quite like this implementation, and if you do too, I will probably package this up and make some tools for it. So you can maybe right-click this wizard state and maybe have a project provider where you can add new state. If you like that idea, let me know. Hashtag Teams tips, use control to zoom in and out on the video window.
It was just in case it's too small on the screen, you can zoom in on the video.
Oh, on Teams itself. Oh, wait, yes, sorry, Teams tips. Yep, got it. Cool. Do you want to have a look at the block diagram? So here I'm changing state. So I exit the previous state. And in exit, I could be cleaning up any references. In reclaim data, this is where I'm collecting all of the leftover user interface data. I'm then replacing it in my state array. I'm using an in-place element structure. The reason I'm using it in this instance is because I'm replacing, I'm always replacing an object in that array. And then I transition into my new user interface. In initialize, I can load all of my states. At the moment, I'm loading those as constants on the block diagram, but you can load this from a file or have some other way of generating this array of objects. Question: Can you tell me how to get the UML add-on into Labview? I'm not sure I have that installed actually. Oh yes, I do. This is part of the Goop toolkit. So in VIPM, if you search GOOP, Goop, you can install it. Oh, now, does anyone have any questions, comments, or thoughts about what we've been through here?
Yes, I haven't tested too much, but get reuse limits.
Is someone asking me a question?
Mm-hmm. But I'm not getting that from the table. Get number of users. And
so I can't tell if you're asking me that question or if you've just got your microphone on.
Today will be.
It sounds like the question's kind of coming through Chris.
Sorry, I think I'm in the office. It's background noise. Sorry.
Oh, okay. Cool. Stephen made a comment. Focus on the content from the ... Oh right. Yes, under more actions, I guess. Yeah, cool. That's all I had to cover. If you do have any questions, comments, or thoughts, I am over time, but message me on LinkedIn. That'd be great. I know that Chris is recording these sessions, so I guess reach out to him.
Yeah, thanks very much, everybody, for presenting. Sam, Tom, AJ, really appreciate it. It's